Hi, I'm Yuval Zukerman.
And I'm John Alexander, and we are here on the first episode of AI from A to Z.
It's where our team at Domino Data Lab will share new updates that we think are interesting and can make your work on AI and data science projects even more powerful than it already is.
And I love power.
Who doesn't? So, John, our colleague Subir recently implemented a truly remarkable work, LLM Cascades with Mixture of Thought, inside of Domino.
Yes, he did, and we were able to validate the author's figures, which, spoiler alert, can save companies a whopping 60% off of their prompt engineering or even RAG bills.
That is amazing. And that's also why we're here to talk about it. So let's start with LLM Cascades. That's a fancy name, but where does it come from?
So the concept of LLM cascades is ancient in Gen AI times from around 2022. Researchers in Google and the University of Toronto suggested data scientists can use multiple language models and can use probability to ensure that their users can capture the best results.
They sound a little bit like ensemble models, don't they?
Well, with ensemble models, you know the model source can train a group of models. Model cascades, on the other hand, deal with black box models like GPT-4 or Claude, and that prevents you from easily training the ensemble yourself. So instead, you ask one model and then another, and that led to Frugal GPT.
Which proposed setting up a series of LLMs ordered by their cost or power, which you can gradually query.
Yes, that paper from Stanford raised the concept of asking LLMs one after the other until you get a good enough answer.
But how do you know when you do have a good enough answer?
Well, my friend, that's where LLM Cascades with mixture of thought comes in, which really is why we're here today.
Mixing it up, so let's talk about it.
Yeah, so this paper from George Mason University and Microsoft makes a bold assumption. You need one strong model and one weaker model, which you can think of as the latest, most powerful, and expensive model, and a smaller, cheaper, older model. But the key is to save money without getting bad results.
Just two models. And how are you figuring out when the LLMs give you a good enough answer when to go from the weak to the strong?
Well, you first need to ask the models the right questions. You see, researchers found an interesting behavior with LLMs. When you send a prompt, the model may be doing its best job for the question. But if you ask it to explain the steps it took to arrive at the question, it actually exhibits better and more consistent results.
And how do you get an LLM to spill the beans?
That's a great question. There are two techniques. One asks the model for steps in text, the other asks it for code. That first technique is called chain of thought, and the second is called program of thought. And this is the mixture of thought approach, and we use both of those techniques. What's also important is that we can measure the quality of an LLM response. We do that by looking at how consistent the response is across multiple prompts. The authors use two techniques here as well: voting, where you count how many answers are consistent, and verification, which compares program of thought answers.
So this paper recommends that you send the weaker LLM multiple prompts of this kind and check how similar the answers are to each other. Hmm. Then use that as the measure of your consistency?
Exactly. And here's the trick. If the weaker LLM is consistent, you don't need to send the prompt to the stronger LLM. That's where the savings are.
So you can see you need when you need a stronger model and
Mhm.
then when you don't. What are the results we were able to recreate from the paper?
So the results were pretty dramatic. Check this out. Using this technique can lead to comparable performance at 40% of the cost of solely using GPT-4. Also, in testing against the CRAPE dataset, which is built on Reddit, the technique outperformed GPT-4 at 47% of its cost. We also verified that the consistency model successfully identified correct answers and can be trusted to flag when and when not to use the strong model to obtain better answers.
That's amazing. And it's a 60% saving like we promised you. So if you want to explore the repo yourself, you can check it out in the link below or sign up to one of the Domino demos, also linked below. Ideally, stay tuned for an upcoming demo of cascading LLMs with mixture of thought on our platform, which we will also link to below once we schedule it. Thank you very much for joining us, and we hope to see you here again.